you've somewhat pessimistically, perhaps, described in this new book genes as a gigantic colony of symbiotic viruses.
I make a distinction between two kinds of parasite, longitudinal and horizontal parasites. Parasites that go down through the generations, call them vertigo parasites, where the way in which the parasite gets itself into the next host is via the gametes, via the eggs, probably eggs, of the present host. That's a vertigo parasite. A horizontal parasite is one which gets into the next host by some sideways route, for example, by being sneezed out and breathed in by another host, or coughed out, or released in the form of diarrhea into the water system and then imbibed. So these are all horizontal parasites. Now, if you think about the possible phenotypic effect, the effect that the genes in a parasite might have on its host, a vertigo parasite, in quotes, wants exactly the same thing, exactly the same outcome as the genes of the host itself. So any gene which has the effect of making the individual host better at surviving, reproducing, better at being a parent, sexually attractive, good at building nests, and all those things, vertigo parasites have exactly the same interests at heart as the animal's own genes. Horizontal parasites clearly don't. Horizontal parasites, for all they care, the host can die, blow up in a cloud of spores and get passed on that way. So if that's right, and is right, that a vertigo parasite, a good example would be mitochondria, which are little organelles inside the host, inside all our cells, which are originally bacteria. They are bacteria, but they've been living in us for billions of years, and they've become totally and utterly symbiotic. We're mutually dependent. And the reason is that they pass to the next host in the eggs of the present host. It only goes down the female line. So that if they had any phenotypic effect, if they had any influence on the host, it would be to the same end as the genes of the host itself, of the human, let's say, itself.